10.3, hypothesis test for population mean. Notice that we're going to go through all those parameters here. Okay? All right, so hypothesis testing regarding the mean. We do need a few things here. It's a randomized experiment, no outliers. The population is normally distributed, or the sample size is large, meaning greater than or equal to 30 of those. And as usual, we're less than 5% of the population size. Okay? Now we still have our two-tailed, left-tailed, and right-tailed hypothesis testing there. So all of those things remain. We just have mu this time instead of a different letter for those things. Okay? Now remember that with population mean, that is a t-test statistic. Okay? So we did our t-distribution when we're dealing with those things. So we want to keep that in mind when we're looking at those pieces. Okay? And so again, we're going to be looking at the greater than, less than, those types of things, and comparing in case we need to reject the null hypothesis. Okay? We can also find the p-value from these as well. Now we're going to be using the calculator to do these things, so we want to look on how to do those pieces. All right? All right, so notice here it does require that we be from a normal population or a large sample size. The procedure is not robust, so minor departures are not going to affect things, but we do want to not include outliers. So if we have a bunch of outliers, we want to discard these, okay? All right, so here we have the mean height of American males is 176.3. The heights of 44 male U.S. presidents have a mean of 180.1 and a standard deviation of 7.1. Treating those 44 presidents as the sample, would this suggest that the U.S. presidents are taller than the typical male, use alpha being 0.05, okay? All right, so we're going to go to stat. Okay, so let's write this down so we keep all this going here. We want to go into stat, over to tests, and then down to t-test. Okay, so stats, test, and t-test. Okay, now we have some statistics here for these, and so we can put in those pieces. All right, now if we had data, we could put in stuff into L1 and do it that way as well. All right, so our mu sub 0, that is the height of all the males, so 176.3. Our x bar, that's going to be for our presidents, is 180.1. Okay, our s here, that's going to be 7.1. Okay, and then our n value, we had 44 presidents. Okay, with us. Now we're wanting to suggest that they are taller, so that's a greater, and so we want to calculate. Okay. All right, so we go through here again. We said that we're comparing those things. We picked out greater than 176.3, just as it said for those, and we want to pay attention to the details here. Okay, so we can see the t-value. They did it by hand there, but they got 3.550. Well, so did we. We got 3.550 there for those. Okay. All right. Now, if we compare that to our 0.05 significance, now we would have to go to our t-table and find that, but we would see that by looking at alpha being 0.05 with 43 degrees of freedom, we get 1.684. Well, our t is bigger than that piece, and so that means that we would reject the null hypothesis. Okay. Now, what about by the p-value approach? Okay, so they still go through and find all those pieces, but then they want to look at where that is. Now, our p-value is very small. We see over here that it's 4.7, but there's e to the negative 4. that means that we move that over 4 places. So it's 0.0004 with those. Okay, it's a very small number on those. Okay, and so they say there it's between 0.0005 and 0.001 on those. Either way, it's a very small number, whether we need to type it in or know it's between those values on that. And it's less than 0.05. Therefore, we can reject our null hypothesis. Okay, so make sure that when you are looking at these numbers, check and make sure there's not an E down at the end there, because if there is, that's going to change where that value is on those pieces. Okay. All right. Now, we can also do it from a table of values. So again, here we can work through that and find those pieces. So let's do it that way. So let's clear this off. We're going to go to stat, but first we need to edit. Now I've got a bunch of values in there, so I need to clear those out. So let's press enter. So let's fill all those in. So 19.68, 19.98, 20.55, 21.50, 20.66, 20.65, 20.36, 19.74, 19.56, 19.61, and 21.02. Okay, so now we can go back to stat, move over to test, select number 2 there of t-test, but this time we have data. So we're going to select the data for those. Now we're going to compare this here. It says it calibrates, so it's supposed to weigh 20 grams, right? So 20 is what it's supposed to weigh for those. All right. And so our frequency is 1 on those pieces, okay? All right, so we see that it's supposed to be actually 20.1. He calibrated so it's a little bit different there, so my apologies, 20.1, didn't read close enough. Can't type either for those. And we think it's going to be different than that for this problem. And so we go down and calculate here as well for those. So we can see our t-value on those, okay? And so when they calculated their t-value as well, 1.042 on those. All right, and so we compare that to our level of significance of 0.01 at 10 degrees of freedom. Now, because it's two-tailed, we got to split that apart and look at it as 0.005, both the negative and the positive there for those. But we are in between those, so we would not reject the null hypothesis. Okay? For those. Do not reject. We can also look at the p-value. Okay, so we go and look at it for those pieces. And so by calculating all those, they do it by hand here for those. But our p-value is 0.322, okay, on those. And so 0.322 is going to be less than our value there, so we do not reject our null hypothesis. Okay. All right, now we also need to look at statistical significance versus practical significance. Okay. Now, practical significance refers to the idea that small differences may have a statistical significance, but in real life aren't really that important. Okay. So, for instance, here we have the Department of Transportation. It says that it takes 29 minutes to get to work with a standard deviation of 8.5. Well, they did this survey and they found 29.3 minutes is what it took to get to work. And so they did the comparison. They think that it's going to be less than 29.3 on those. And so when they look at it, they see that it actually is that we would reject the null hypothesis because of where our test statistics come out for those. Okay? Now, when we actually do, so we're doing all that work there on those. But when we actually do that, it's a 0.3 minutes. Well, that's 18 seconds. Does 18 seconds really matter? No. When we're talking about driving down the road, 18 seconds is not significant. Now, if you're looking at 18 seconds in a 10-second race, yes, that's significant. But in 29 minutes, 18 seconds really doesn't affect anything for those, okay? So we do want to look at those things and consider the practicality of that significance. All right, so those are the things that you're going to need here in 10.3.